Assalamualaikum warahmatullahi wabarakatuh. In this video, I will present to you my final year project on title Cutting Temperatures and Their Effects on Drilling of NFRP Composites using Taguchi method. NFRP is a short form of Natural Fiber Reinforced Polymer Composites. This composite is a product of combination of natural fibers such as knaf, jute, sisal, and bamboo with the polymer matrix to form NFRP composites. There are two types of polymer matrix that usually used to make composites, which are thermoset and thermoplastic. So this is the properties of NFRP composites, which are high strength to weight ratio, lower cost, not dangerous to human and environment, and biodegradable. In Malaysia, Proton and Produa use knaf composites to make trim components such as door panels, seat backs, headliners, and package trays. Drilling is a type of machining process that involves the cutting out or enlargement of holes in a solid material. These are the parameters of the drilling. First, spindle speed, feed rate, and tool geometries. These parameters will affect the quality of the final product. So this figure shows the drilling mechanism. This is the rotation of the spindle, which required to remove the material, and the feed is applied for the drill bit to penetrate into the workpiece. NFRP composites have characteristics that are inhomogeneous and anisotropic. These characteristics will result in delamination and rough surface when drilling, and it will give a problem in assembly of the mechanical components. It was reported that the defects such as delamination cause up to 60% rejection in case of aircraft assembly. During drilling, the excessive heat may destroy the matrix. The critical degradation temperatures range of epoxy-based matrix is from 180 Celsius to 270 Celsius. If the temperature during drilling is too high, which means it reaches this temperature, it will soften the matrix and it will affect the bonding between matrix and fiber. The objectives of this project are to examine the effect of machining parameters on heat dissipation in drilling and FRP composites through Taguchi method. Secondly, to determine the optimum machining parameters in drilling of NFRP composites. Now, we move to the next slide, which explains the effect of drilling parameters on the cutting temperature. First, speed. Increasing in speed will result in higher temperature. It will increase the friction between the tool and wood surface. The friction will generate heat and it will result in the rising in temperature during drilling. Next, feed rate. The higher feed rate will reduce the temperature. This is because of the reduction of time where the tool and workpiece are in contact. Lastly, the point angle. Higher point angle will increase the temperature. This is because of the greater point angle will increase the frictional contact area of the tool and the workpiece. So, this is the methodology of this project. The function of design of experiment is to find the relationship between input of the process and the response. In this experiment, the input of the process is spindle speed, feed rate, and point angle, and the response are the surface roughness, delamination, and tool wear. In this experiment, Taguchi method will be used to analyze the data in order to get the optimal result. This method may systematically reveal the complex cause and effect relationship between parameters and the performance, and it will give optimal result with minimum runs of experiment. So this is a purpose and list of equipment that will be used in the experiment. And the workpiece that will be used is woven knauf epoxy composite. And this is the detail of the composite. And the list of equipment that will be used is uncoated carbide twist drills, CNC milling machine, thermal imaging camera, tachometer, optical microscope, and scanning electron microscope. And this figure show the experiment setup, and thermal imaging camera will be used to monitor the temperature during drilling, and tachometer will be used to observe the speed. The data of the experiment will be analyzed by using Minitab software in order to get the optimum result. And this is the set of parameters that will be used in the experiment. And this is the response to the experiment, which are surface roughness, delamination, and tool wear. Surface roughness occurs when the uncut chips still attached to the wall of the holes after drilling is done. In order to minimize the surface roughness, most researchers suggested to machine them with high cutting speed, low feed rate, and high point angle. These parameters will result in rising temperature. When the temperature increases, the material will enter the ductile deformation zone, and it will result in better surface roughness. Next, delamination. Peel-up delamination always occurs at the entry of the holes, and push-up delamination always occurs at the exit of the holes. Delamination can be reduced with the minimum thrust force. To minimize thrust force, most researchers suggested to machine with high speed, low feed rate, and low point angle. And this is the formula to calculate the delamination factor. Next, tool wear. Tool wear refers to the bluntness of the cutting tools after being used many times. And cutting temperature is an important factor that influences the tool wear. The high cutting temperature will cause the reduction in tool wear. And to minimize the tool wear, we can drill the FYP composites with high speed, low feed rate, and high point angle. This table shows the expected result in this experiment. In conclusion, the parameters such as speed, feed rate, and point angle are highly influence the temperature during drilling. The high speed, lower feed rate, and higher point angle will result in high temperature during drilling. In this project, the high temperature will result in better hole quality. But if the temperature is too high, it will damage the composite. And to minimize the surface roughness, delamination, and tool wear, the best parameters that can be used to drill the FRP composites are 2500 RPM spindle speed, 0.3 mm per revolution of feed rate, and 135 point angle. If you have any question regarding this project, feel free to contact me via email. And that's all from me, and thank you for watching this video. Assalamualaikum warahmatullahi wabarakatuh.